Construct the image of the square BCDE under the enlargement with center O and scale factor 0.5. What we do is draw straight lines from the center of enlargement to the four corners of the square, or the corners of whatever object it is. Now the scale factor is 0.5. So what we do then is we take one of these lines, say OE, and multiply its length by the scale factor. So we multiply OE by a half. In other words, we get a half of OE. And half of OE would be OE prime. E prime is the midpoint of O and E. So the image of E under this enlargement is E prime. Now, to get E prime, we could just get the length of OE with a ruler, just get half that length and measure out the distance OE prime, so such that OE prime equals E prime E. Make these two lengths the same. Or you could use a compass to find this point. Put your compass point at O, set the compass to more than half the length of OE, and make an arc on the other side. Then, with the same extension on your compass, place the compass point at the point E and make two more arcs. Then join the intersections of the arcs. This line here is the perpendicular bisector. It's perpendicular to OE and it bisects it, so that OE prime equals E prime E. So now we've found the image of E under this enlargement. Well, this is not really an enlargement because the scale factor is less than 1. We're actually scaling down this square by 0.5. If the scale factor was greater than 1, then we would be scaling up this square. What's happening here is that the side of this square will get multiplied by 0.5. So the side of the image of this square will be half the length of this square. Now, how do we get the image of B? Well, we could bisect the line joining O to B, and we would get the point B prime. We can call it B prime, the image of B. Then join E prime to B prime. And E prime B prime is the image of the side EB. You will see that E prime B prime is half the length of EB. We could also get this line by drawing a line through E prime parallel to the line EB, because these two lines will actually be parallel. Okay, then we need the image of D. Well, we can get the midpoint of OD, or we can draw a line through E prime that's parallel to ED. So E prime D prime is parallel to ED. We can get the midpoint of OC, which is about here. That gives us C prime. So B prime C prime is parallel to BC, and then we can complete the square. This is supposed to be a square. Now, one thing about enlargements, when an object is scaled up or scaled down, it's actually scaled down in this case, is that angles don't change. So the angle between EB and ED is 90 degrees, and that's the same as the angle between E prime B prime and E prime D prime. So this shape will be exactly the same as this, but you know, this is a square, so all the angles are 90 degrees. So all the angles in this shape are 90 degrees as well. PQR is a right-angled triangle. WXY is its image by an enlargement of scale factor 2. So if we wanted to construct the image of PQR under an enlargement of scale factor 2, we would draw lines from the center of enlargement, which is O, through the three corners of this triangle. So for example, we draw a line from O through P, and we keep going. What we do then is we multiply the distance OP by 2, and we would get the line that's twice as long as OP. We get the line OW. So OP would equal PW, because OW is 2 times OP. So the ratio here would be 2:1. So then we would have the image of P. This would be P prime. Well, it's called W here. To get the image of Q or Q prime, we draw a line from O, the center of enlargement, through the point Q, and we take this line, multiply by the scale factor. The scale factor here is 2. Like in the last example, the scale factor was a half, so we would be getting a half of OQ. We would have this point here. But since the scale factor is greater than 1, the image of Q is a point that is twice as far from O as Q is from O. So this point here would be Q prime. It's called X in this case. Then we draw a line from O through R, double it, and we get OY. That's how we could find the corners of our image. So we would make OP equal to PW, we would make OQ equal to QX, and we would make OR equal to RY. Well, this would be R prime, it's called Y here. And then we just join them up. That's how we construct the image of a triangle under an enlargement. Enlargements preserve angles. Angles aren't affected. So the angle between QP and PR won't change. So the image of QP is the line XY. By the way, QP will be parallel to XY. The image of the line PR is WY. PR will be parallel to WY. And the angle between QP and PR is 90 degrees. So the angle between XW and WY will be 90 degrees. That won't change. So triangle WXY is a right angle triangle. Now the scale factor is 2. So that means that each side of triangle PQR is multiplied by the scale factor. So PQ is 2.5 units long. So the image of PQ, which is WX, is twice as long as PQ. So 2 times 2.5 is 5. So the length of WX is 5. Now we're given that the area of triangle PQR is 3 square units. So I'm writing the 3 inside here. What does that tell us about the area of this triangle here? Is the area scaled up by a factor of 2? So is the area of WXY equal to 6? Well, actually it isn't. It turns out that the area of WXY is more than 6. The sides are scaled up by a factor of 2, but the area is different. To give you an idea of what happens, let's say we want to get the area of this triangle here. Well, we could use this side as base, it's 2.5, and this side as the perpendicular height. You see, the perpendicular height is actually one of the sides of this triangle because it's a right angle triangle. We halve the base by the height. Basically, we'd be multiplying the base by the height and dividing by 2. To get the area of this big triangle, we'd be multiplying, if we take this as base, 5. See, 5 is twice 2.5. We'd be multiplying 5 by this perpendicular height. But notice that this perpendicular height here is twice this here. So we'd be multiplying 5 by a number, whatever this is, which is twice this number here. So when we're getting the area, we have a factor of 2 appearing twice. See, when we scale up this side by 2 we get 5, but when we scale up the other side by 2 we get whatever. Well, we don't know this yet, but as for the area, you'll have a factor of 2 appearing in this side and in this side. So when we multiply these two sides to get the area, a factor of 4 will appear. The scale factor is 2. It turns out that the area scale factor, that's what I'm calling it, is got by getting the scale factor and squaring it. So we take 2, which is the scale factor, and square it, so we get 4. So the area is scaled up by a factor of 4. So we multiply 4 by 3 to get 12. So the area of WXY is 12. Now, in the next question, we want to find the length of WY. We want to find this length here. Well, the area of triangle WXY is half base by height. So if we take this as base, as I explained earlier, and this is the perpendicular height happens to be one of the sides of this right angle triangle because it's right angle basically. So half the base by the height equals 12. So a half times 5 times the length of WY is 12. So we solve this. We can multiply both sides by 2. and divide by 5. Multiplying both sides by 2, we get 5wy equals 24. wy equals 24 divided by 5, which is 4.8. Triangle XYZ is the image of triangle BCD under the enlargement center A with BD equal to 4 and YZ equal to 7.5. The scale factor of the enlargement is 1.5. That means that if we take, say, the distance AC and multiply it by 1.5, we will get AY. Y is the image of C. You could also call this point C prime if you like, the image of C. So that means that this side of the triangle XYZ is 1.5 times larger than this side here. This is the corresponding side. These are parallel. The same goes for any other ray. I mean, AZ will be 1.5 times AD, AX will be 1.5 times AB. The line XZ will be 1.5 times BD. So we can actually find XZ because it's 1.5 times 4. So as I just said, XZ is 1.5 times BD, 1.5 times BD, or 1.5 times 4, which is 6. Also YZ, which is 7.5, is going to be 1.5 times CD. So YZ and CD are also parallel lines. So to find CD, we just take 7.5 and divide by 1.5. Well, that's just 75 divided by 15. That's 5. If the area of the triangle BCD is 3.79 square units, what is the area of triangle XYZ? Now, as I explained in the last example, the scale factor for the area is got by squaring the scale factor. So the area will be scaled up by a factor of 1.5 squared. So here we have the area scale factor. So if we want the area of triangle XYZ, we multiply 1.5 squared by the area of triangle BCD. So 1.5 squared by 3.79 is 8.5275.